Analysis and Design of Algorithms Laboratory BCSL404 Program 3B. Design and implement C program to find the transitive closure using Warshall's algorithm. So for a given graph we have to find out the reachability or path from vertex I to J in any given graph. So the reachability can be represented using the transitive closure of a graph. So here for example, in this given graph you can see the transitive closure matrix is represented towards right side. So here these 1 2 3 4 represents the nodes. So we have 4 nodes, and here 1 to 1, so 1 is reachable. So from node 1 to 1, obviously the self node means the path exists itself. So we the transitive closure represents its reachability is 1, and 1 to 2. So 1 to 2 you don't have any direct edge or any other intermediate path also. So the reachability from 1 to 2 is 0. So 1 to 3 also there is no outgoing edge from 1 to any of the other vertex. So obviously there won't be the reachability or path from 1. So that is why these entries are 0. So 1 to 2 is also 0, 1 to 3 is also 0, 1 to 4 is also 0. So here from 2 to 1, let's see 2 to 1. So 2 to 1, yes, though there is no direct edge from 2 to 1, but we have a path from 2 to 4, 4 to 1, it's reachable. So that's why the entry is from 2 to 1, the reachability is 1. So 2 to 3 also there exists a path to, that is 2 to 4, 4 to 3. So that's why the entry is 1. And 2 to 4 obviously there's a direct edge, so the path exists. So in the similar way, for between the reachability between other nodes is represented in a transitive closure matrix. So this transitive closure matrix, we define it as a path matrix, so which tells that a particular node J is reachable from I or not. If it is reachable, if the path exists, then the entry will be 1. If the path does not exist, then the entry will be 0. So here there's another example. There are 4 nodes A, B, C, D, and this is the adjacency matrix. So adjacency matrix tells you whether there is a direct edge or not. If there is a direct edge, then we give it as 1. If there is no direct edge, we give it as 0. So A to A there is no direct edge, 0. A to B there is a direct edge, so we give it as 1. A to C there is no direct edge, so it is 0. A to D also there is no direct edge, so it is 0. Similarly, B to A there is no direct edge, 0. B to B there is no direct edge, 0. B to C also there is no direct edge, so it is 0. B to D there is a direct edge, so it is 1. B to then it is C to A. C to A there is no direct edge, so it is 0. C to B also there is no direct edge, so it is 0. C to C there is no direct edge, it is 0. C to D it is no direct edge, so it is 0. Then D to A there is a direct edge, so it is 1. D to B there is no direct edge, so it is 0. D to C there is a direct edge, so it is 1. D to D so there is no direct edge, so it is 0. So this is the adjacency matrix. So using this adjacency matrix, we will be able to find out the path matrix or transitive closure matrix of the given graph. So the input in this particular program, we are going to give the input in terms of adjacency matrix. For a given graph, we are going to give the input in the terms of adjacency matrix, and the output we are going to get as a transitive closure matrix, which represents the reachability, which we term it as a path matrix. So here the matrix C here represents the path matrix. So that would be the output of the program. So let's see the program. So header files, and we are declaring two-dimensional arrays. One is A and P, where A represents the adjacency matrix and P represents the path matrix, and N to for the number of nodes we are declaring N. So all these are of type integer. Then we are defining a function, user function path, First we'll see the main function and then come and look into the implementation of the path function. So in the void main, we are declaring two variables, local variables I and j for the iteration purpose, and we are asking the user using printf function to enter the number of nodes, so which we will be storing it in n, number of nodes, and then enter the adjacency matrix. I told you earlier also during the explanation, we are going to give the input in terms of adjacency matrix. So to take the input for a adjacency matrix, so obviously it is two dimensional, so we will be using two for loops I and j. That is why we had declared two variables here. So I from 0 till it will run till I is less than n, means number of nodes, and j is equals to 0 till n. It will store it in a of ij. So the adjacency matrix, here we were storing the adjacency matrix, right? These entries will be stored. Then we are going to call the function path. So once we call the function path, we'll see the implementation of path function. So in path function, again we are declaring three local variables I, j and k of type integer for iteration purpose. So I is equals to 0 till n and j is equals to 0 till n, the whatever adjacency matrix that we had initialized in the main function will be copied to path matrix P of ij. So all the entries will be copied to P of ij. Now here we have to update P of ij based on the reachability, whether the node j is reachable from I if the path exists, right? So for k is equals to 0, k is less than n, k plus plus, and I is equals to 0, I is less than n, I plus plus, and for j is equals to 0, j less than n, j plus plus, till the number of nodes I, j and k reaches the number of nodes, that is 4 in the case, or whatever the number of nodes that would have been entered till it reaches n. What we are going to do, we are going to check for p of ik equals 1 and p of kj equals 1. P of ik equals 1 means there exists a edge, whatever adjacency matrix we would have entered as 1 or 0, right? So if the path or an edge exists between ik, then it will be 1, and from k, if there a path exists to the destination, that is j, which we were wanted to find out, I would be source and j would be j would be destination and k would be the intermediate node. So from I to k the path exists, and from k to j the path exists. If both edge exists, then the path between I to j exists. So we are going to rewrite P of ij is equals to 1. If the path does not exist, we will not do anything, we will not change anything. Obviously the entry there would be in the adjacency matrix would be 0, and the same thing we have copied in P of ij, so the same thing remains as it is. Only if the path exists, then we are going to update it, or else we will keep the path matrix, whatever the entries were there in the adjacency matrix that we had copied, as it is. Okay, so when path exists, we are going to update it as I is equals to 1. So once we are done with all the nodes, here we had called the function, right, path. So the path matrix is shown below, and the heading we are going to print, and for I is equals to 0, I is less than n, I plus plus. For j is equals to 0, j is less than n, j plus plus. We are going to print all the entries of P of ij, including the updated entries, right? After the function call, we are going to call this particular path, right? So we will be printing all the entries of path matrix P of ij, and then after every row a new line will be printed. For that purpose, printf n /n we are using here. So that and that's the end of this particular program. So the output here is enter the number of nodes. Suppose we are entering 4, and this is the adjacency matrix. So enter the adjacency matrix. So we will enter as 0, 1 in terms of 0 and 1. If the edge exists, then we are going to enter it as 1. If the edge does not exist, means direct edge does not exist, then we are going to enter it as 0. Then all these adjacency matrix will be copied into path matrix, and then we are going to compare if there exists a path between A to B. Suppose we want to find out A to C, and via B means A to B, B to C. If there is a path, then obviously you can reach A to C. There is a path exists, right? So we will mark it as 1. The path obviously exists. So same thing, it keeps on updating for every node. It verifies and updates the path matrix. So finally the path matrix will be printed. So this is the output. Thank you.